In this video overview, we're going to discuss some of the aspects of importing a pre-made 3D model into Aspire. If we go ahead and click on the Modeling tab, the icon to import a model is under the Modeling Tools, and here it says Import a Component or 3D Model. If we click on this, we have the ability to import a file that was saved previously in Aspire, and if we select something like that, what it's going to do is import essentially what was the composite model at the point where it was saved. Also, if we look at the files of type here, we have other relief style files like Vector Art 3D V3M files, or mesh style files which tend to be complete 3D objects such as an STL. To start with here, let's just bring in a standard kind of relief style piece of artwork such as the clip art that comes with the software. We'll click on this grape leaf, hit OK. You can see when it's imported it'll be located at the position that it was saved in. I can click on it though, move it around and edit it just the same as I can if it was a component that I'd created in the software. And I'll also have that item added to the list here in the component tree and given the name that the original file had. Now in this case the original file only had a single component in it, but it's also possible to bring in the result of files that have many components in. If we go ahead and just delete that component there, I'm going to come back to the Import a Component and we'll click on a part that was created from a number of different components all put together. When we click on Open, we're going to see that the part is much larger than the one that we're bringing it into. If I zoom out here, we can see how large this part is. Only the part that I can see within my work area is going to be displayed in the 3D view. We can click on this though and go ahead and shrink it down in order to fit inside of our model. And there we can see we've now got a single component which is made up of whatever the composite model was of the part that we imported. Now we could go ahead and work with that again just as if it was something we'd created in this session of Aspire. And this is one of the most powerful features of Aspire, is the ability to be able to create something in one session and then to use it in others, essentially as a piece of clip art. Let's go ahead and select and delete that file now. The next type of file that I want to show you being imported is a mesh file. Typically, file format you may find for something like a mesh is going to be STL or a 3D DXF. But it has to be a mesh. It cannot be a wireframe file. It needs to have some sort of a skin to it to be able to import it into Aspire. Let's go ahead and click on the Import a Component icon again, and this time we're going to choose a file that I downloaded off a website called Porsche.stl. We'll go ahead and hit Open. If we maximize the 3D view, we can see in the 3D view that this model is a completely 3D object. It's not a relief style model which we have been importing so far. This means that we need to orientate the model, position it and size it so that we're going to be able to convert it back into a relief style model so that it can come into Aspire. So the first thing is to look down the Z-axis as I am here and orient the model so that we can see the part we'd like to convert into a relief style model. So I'm going to come up to the top surface and I'm going to click that that's the front, and that's going to rotate the model around so that I can see the part that I would currently get if I hit OK is the part here above the plane. Now we can see that this model is very faceted, and that's fairly typical of these mesh style models, particularly ones you might find on the web that were created for use in games or animation. And unfortunately that faceting will come through to the model when you convert this and bring it into Aspire. The other thing that will happen when we convert it and bring it into Aspire is we're going to lose any undercuts. Aspire won't support the undercuts. It has no way of representing them within the model. That means that the wheels will all be filled in here, and also if we've got something like the aerial we can see coming up off the top of the car, that is going to create a long thin plane down to the modeling plane. That's a bit of a problem in this case because that's going to be too thin to machine or do anything sensible with. So in reality what I'd like in this case is probably to have the other side of the car. So I'm going to click on back, and that'll flip it so that now the aerial is in the part that I'm actually going to get rid of. The fact that it's upside down is not a problem because once this becomes a component I'll be able to change its orientation again and rotate it around if I want to. Next, we need to edit the size, and we need to create this to be the size that we plan to use it at. And ideally this should fit within the work area of the job, because otherwise the model is going to be cropped. The work area we set up for this was 12 by 6, so I'm going to come in here, and with the lock XYZ ratio checked, I'm going to type in an X value of 10, and we'll see that that automatically adjusts the other values because that parameter there is currently checked. If I want to uncheck that, I could go ahead and independently scale these. So perhaps I want to change the Z value to be 2 and hit apply, and we can see that's going to squash the model down now so that it's only 2 inches thick. And that may result in some loss of detail. I would have to look at the model carefully to see what effect that was having. If the model was in metric or inches, I have the ability to scale it here. And then finally I'm going to choose how much of the model I want to be converted. I can move its position relative to the plane. You can see the plane cutting through there. And because I have it set to discard data below 0 plane, currently it's going to get rid of everything below that. If I had the style of model where the data I wanted to keep was negative, for instance a dished model, then I would need to uncheck this to make sure that it didn't discard the data below the 0 plane, because otherwise I would probably lose that with that style of model. Here I'm just going to click on middle to put it in the middle. I'm happy with the way that looks, other than I would like to tilt the nose up slightly before I convert it. Now the only way to change the orientation other than to use this top surface and rotation here is to hold the shift key down and to rotate it. If we hold the shift down and click and rotate, you can see that I can actually move the shape around within the model. So we can rotate it into a different orientation. There you can see I've tilted up the front end of the part, and now this is how it's going to be converted when I go ahead and hit OK. So let's hit OK now on the menu, and that's going to take the file, use the parameters we set there, and it's going to create a component for me. If we tile the windows, we can see the grayscale preview. I can see what the 3D component looks like, and I can also see that a component's been added to the tree with the same name as the file we imported. I could select this now, and we could rotate it around to put it into the right way up. And we'd be able to use this as we would any component that we'd imported in another way or that we'd gone ahead and created ourselves. As I mentioned, you can see the faceting in the model, and also if I tilt this up you can see that the undercuts under the wheels have all disappeared as I said they would. As well as importing an STL file, we also have the ability with Aspire to export an STL. Let's just go into another copy of the program so I can show you how you would do that. If we go up to View and Tile Windows Horizontal. So if you have the need to take something you've created in Aspire and export it as an STL, perhaps to take it into another CAD system or to export it so that you can build it on a rapid prototyping machine, then you just come up to Model, come down to Export as STL. So it's going to give you the ability to type in some kind of triangulation tolerance. If I click on triangulate, then it's going to generate a mesh from that. If we zoom in, you may be able to see some of the faceting there. And then I would hit save, and I would just save that as an STL file. Just to show you what I mean by the faceting, if we make the tolerance something like 0.1 and hit triangulate, now we can see very clearly these triangles that we saw on the Porsche when we imported it. These triangles are a product of the tolerance that the file was saved at from whatever the sending system is. So there's no way to get around those on files that you receive. From the files we save in Aspire, you just want to make sure that you use a value that's tight enough to give you a part that's smooth or looks smooth enough so that it'll be okay for whatever application you have in mind for the STL file. One other way to export and import 3D data from Aspire that's worth mentioning is the ability to do it as a grayscale image. If we have an object here, we can come up to Model, we could come down to Export as Grayscale Bitmap, and we have a choice of exporting as a bitmap, JPEG or GIF, or we have the ability to export this as a 16-bit TIFF, will be a much higher quality image. And if you wanted to export this in order to engrave it on something like a laser, or perhaps to take the file and use some of the effects you might find in a program like Photoshop on the file and then to bring it back into Aspire, you would use that 16-bit TIFF option. And I would recommend reading about that in the reference manual. To import a 16-bit file, we would go ahead and just come over to create a component from selected bitmap. When we click on it, we can come out and select the file of an appropriate type, and it's going to automatically generate a shape from the image. And you'll see that covered in many of the tutorials where we take images and bring them into the software in order to create shapes. That concludes this video overview on importing and exporting certain types of 3D data.